I want to take what we learned yesterday, distance, position, displacement, and time, and extend that to calculations involving what we call uniform motion. Uniform motion is motion in which the velocity or the speed isn't changing. It's like you set your cruise control on the highway at 110 kilometers per hour, and you go 110 kilometers per hour the whole time. You're not speeding up, you're not slowing down. Let's define a couple terms here, speed and velocity first. Speed, anybody got a good definition for speed? This is one of those ones kind of like distance. There's all kinds of different ways you could say it. Marshall? Yeah, you could say that, the rate at which an object travels. Yeah?
How long it takes to go a direction.
Be careful with that. I know what you mean, but when you say how long it takes to go direction, okay, then you're talking about a time, right? How long it takes is a time. I know what you mean by that. You just got to be careful with your wording of that, right? Yep.
How fast an object.
Yeah, I was going to say how fast something's moving. We don't have to make this more complicated than it needs to be. Let's just say how fast something moves. The symbol for speed is a V. That's a lowercase v, by the way, rather than an uppercase V. We don't even see any uppercase V's in Physics 20. In Physics 30, an uppercase V would be a unit called voltage or electric potential. But that's for another day, another year, actually. Want to take a stab at what the units would be for speed? The standard units, that is, for speed. Sometimes we use other units, but the standard units, Tyler, would be? Yeah, meters per second. If we're going to use meters for distance and we're going to use seconds for time, then speed would be meters per second. You think that's a vector or a scalar? You remember the difference, right? Vector serial has magnitude and direction, right? Vector is magnitude and direction. Scalar is just magnitude. What do you think this is? This is scalar. The speedometer on your car measures speed, the scalar equivalent of velocity. When we look at the speedometer, it doesn't say you're going at 110 kilometers per hour to the west. It just says 110 kilometers per hour, right? The speedometer measures speed, measures a scalar. Velocity, we're going to define in a little bit more scientific sounding way, just because of what it means, how we're going to calculate it. We're going to define velocity as the rate of change of position. The rate of change of position. Rate means how quickly something happens. So the rate of change of position would be how quickly the position is changing. The rate that the position changes. The symbol for velocity is going to be V. Anyone? With the little arrow. Not a delta V. We're not talking about a change. Remember, we're talking about uniform motion. Uniform motion means the velocity is remaining constant. So there is no delta V. Delta V would be 0. We're just talking about V with the arrow over it because it's basically speed with a direction. By the way, speed and velocity will be the same number if we don't change direction. Speed and velocity will be different numbers if we change direction. What are the units for velocity? Yeah, meters per second, and velocity is good. Now we got two equations here. Really, it's the same thing, almost. We only put one of them on your data sheet because they're pretty much the same. The speed would be distance divided by time. The distance divided by the time interval. Velocity is going to be displacement divided by time. Why displacement divided by time? Well, because we define velocity as the rate of change of position. The rate of change of position, change of position is displacement, and the rate of displacement is displacement over time. If you take a look at your data sheet, you can see that the equation for velocity is there in the top left-hand corner. The equation for speed is not there. But I think you guys are all smart enough to figure out the equation for speed given the equation for velocity. You just drop the arrows over it, right? You just make it delta D over delta T. Now, there's one thing that I want you to remember for this. These equations are valid for uniform motion. That means they're valid only when we have a constant speed or an average speed. So if you're not changing speed or not changing velocity, you're traveling on the highway with your cruise control set at 108 kilometers per hour, these equations are valid. If you're speeding up, these equations aren't valid, unless you're asked for the average velocity. Drive to Edmonton at a constant speed, use this equation. Drive to Edmonton, change your speed. If you're asked for the average speed, then this equation is valid as well. But if the question says a car accelerates, blah, 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 what is the acceleration, blah, 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 what's the final speed, blah, 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 you can't use these. It's only for constant or average speed / velocity. Now I'm going to make a little note on my data sheet here. I'm going to ask you to do the same. Circle V is equal to delta D over delta T and put a little A beside it. We're going to group these equations under kinematics through this unit as we go through the unit. This is our group A equation. Every time we have constant or average speed or velocity, we use our group A equation every single time. Now, one more thing before we do an example. There was nothing to rearrange, nothing to do algebra on yesterday. Today there is. Sometimes you're going to get a question that asks you for the speed or the velocity. If that's the case, then good, just use the equations given to you. But if you're asked to solve for distance or displacement, or you're asked to solve for time, we've got to figure out how to get distance or displacement or time from these equations. So we got to do a little algebra. And sometimes we're not very good at that. What I don't want you to do is that stupid triangle that you've learned in junior high school. It's only good if you have a 3-variable equation like this. It would actually work for this equation, but it's terrible. Don't ever use that, because it only works for simple equations like this. We're going to see much more complicated equations. You need to know how to do the algebra, not how to do some silly little triangle that's a little trick for simple little equations like this. So I'm going to show you how to do that algebra here right now. If we want to solve for delta D, the distance, or the displacement, we're going to take our speed equation, and we're going to do what with it? We're solving for delta D. We got to get rid of the delta T. So what are we going to do? Times it. Yeah. Essentially what you're doing is multiplying both sides by T. Right? If you say V times T equals delta D over delta T times T. See what I did there? I multiplied both sides by T. T cancels right here. And what am I left with? D is equal to V times T. I'll be honest with you. Usually when I'm rearranging equations like this, I don't show that middle step. I know that if something's on the bottom, to get it to the top, I have to multiply it. Does that make sense? Now, what if I'm solving for delta T? Well, if you're solving for delta T, you got to get T to the top. It's on the bottom here. You got to get it to the top first. And I just did that. So what you have to do is essentially solve for D first. We're going to start with this equation. D is equal to V times T. And then to get rid of V, I'm going to take it over by V is multiplied by T. So to get rid of it, I divide it. I do the opposite of it, right? To get rid of T, I do the opposite of divide. I multiply. To get rid of V, I do the opposite of multiply. I divide. So my answer becomes T is equal to delta D over V. I skipped that middle step, right? Really what we're doing is dividing both sides by V, cancels out on the right-hand side, and I'm left with this. Delta T is equal to delta D over V. Does that make sense? That might seem a little bit harder than that silly little triangle right now, but trust me, in the long run, we got to be able to do it this way. Okay, the triangle's not going to work for us for most things this year. Got it? Yeah, let's do an example here. It's example number 3 in your booklet. It says Regina is 600 kilometers west of Winnipeg. Calgary is 1,350 kilometers west of Winnipeg. It takes a car and its driver 8 hours to get from Regina to Calgary. What's the car's average speed and velocity? In 1995, 13 years after that other mistake that I made, I was driving across Canada for the first time by myself after having got this job. Never been west of Ontario at that time. Get in the car, pack it up, and just start driving. It took me 5 days, 5,100 kilometers, 5 days. My biggest day was 1,700 kilometers one day. Get tired, right? Got to Winnipeg. So I got to Regina, and I see the sign for Calgary. Like I see, like it says Calgary, this many kilometers. And I'm getting excited, right? Because I grew up in the East Coast. And on the East Coast, when you see those signs that say this city is this far away, like everything's so close together out there that it'll say like Halifax, like 37 kilometers or whatever, right? You know, at most it might be like 90 kilometers. Like everything is so close together. So I'm used to seeing signs like that when you see the sign, it means you're close. So I see the sign for Calgary on this side of Regina. Calgary, I get closer. How far is that? 800 kilometers. It's a little depressing. I like driving. I like road trips. But on that last day, when you see that sign that says Calgary, you start getting excited. And then you see that it's still 800 kilometers away. It's a little depressing. I made it that day, but it was a little bit longer, a little bit later than I planned on. Look, Regina, that's what this question is based on here. Regina is 600 kilometers west of Winnipeg. Calgary is 1,350 west of Winnipeg. It takes a car and its driver 8 hours to get from Regina to Calgary. What's the car's average speed? What do we need first? If we want to find speed, we need distance, right? Okay, let's get the distance traveled. What's the distance traveled going to be here? Yeah, it might be useful to draw a map here, right? This is Winnipeg. Hey, this is Winnipeg right here. Regina is 600 kilometers west of Winnipeg. Here's Calgary. Calgary is 1,350 kilometers west of Winnipeg. I went from Regina to Calgary. What's my distance traveled? 750 kilometers. Do I need the direction? No, I don't need the direction, right? Because distance is a scalar. What's the time? 8 hours. We're going to look for speed here. Now, in this question, typically we're using meters and seconds. We don't have to here. We're calculating speed. We're allowed to use kilometers and hours if we want, if it's convenient. Seems to be convenient here, right? Kilometers per hour is a pretty normal unit, pretty recognizable unit for speed. Let's just use that. Say 750 kilometers divided by 8.0 hours gives me 93.7? 93.75? We'll make that, we're going to make that 94 kilometers per hour. Anybody know why I'm rounding it to 94? Yeah, it's significant figures, significant digits here. You guys know that? Significant figures from chemistry or from Science 10? Where do you round to? Well, this is 3 digits, right? This is 4 digits. This is 3 digits. Our final answer is going to be the least precise piece of data. Think about that, right? If you're taking measurements and you've got 4 measurements that are really, 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 really precise, but one measurement isn't very precise, then your final answer can only be as precise as your weakest piece of data, right? You ever heard that expression, a chain is only as strong as the weakest link? Right? Your answer can only be as strong or only be as precise as your weakest piece of data. So this is 3 digits, 4 digits. This is our weakest piece of data that's 2 digits. Our final answer is going to be 2 digits. Got it? Okay, let's do question B, and then we'll let you work on a couple questions here. B says, what's the average velocity? Well, we need displacement for this. What's the displacement? What is it? How do you know it's the same thing?
Because it's
Yeah, I haven't changed. Yeah, it's final minus initial. I can say, let's go df minus di if you want. df is, what, 1350 minus 600, which is 750. By the way, I'm defining west as positive here. If I define east as positive, what would my displacement be? Negative 750, right? But because I'm going west the whole time, I just thought it would be easier to make west positive. Did we really need to subtract those? We didn't change direction, did we? So we knew the distance would be the same number as the displacement here. Okay, we know the time is 8.0 hours. We're looking for the average velocity here. And the average velocity would be displacement divided by time. It's going to be 750 kilometers divided by 8 hours. Oh, look at that, we get 94 kilometers per hour again. How come it's the same number? Because we didn't change direction. What's the positive mean here? I usually like to write that in there. What's the positive mean? Yeah, it's to the west, right? Because we defined west as positive. Again, you define east as positive, that's fine. What would you have gotten for an answer? Negative 94 kilometers per hour, which would have meant west, opposite to east. Got it? You guys have all done these calculations before, right? Just kind of intuitively, right? And now you have a way to formally do it when the questions get a little bit tougher, like, 750 in 8 hours, right? If it's 800 kilometers and it's 8 hours, that's easy. But if it's 750 in 8 hours, we need to have a way to formalize it a little bit more than the easy ones. More than the 80 miles per hour, 80 miles question. All right? Let's have a look, please, at worksheet number 2. Right now, I want you to do questions 1 to 4 only. Questions 1 to 4 only on worksheet number 2.